All right, we're in section 8.4 where we are looking at properties of rhombuses, rectangles, and squares. So in 8.2, we talked about the properties of parallelograms. So to recap, we stated that a parallelogram has two pairs of parallel sides. We said that their opposite sides were congruent. We said their opposite angles, interior angles, were congruent. We stated that the diagonals, as you made two line segments in between them, they bisected, and that seems about it. And rhombuses, rectangles, and squares are all part of the parallelogram tree. But rhombuses, rectangles, squares have their own specific qualities. So on top of those qualities that parallelogram has, we're going to try to list uh, as much as possible for rhombuses, rectangles, and squares. So in class, I asked the class to list as much as they could. So what I would ask of you in this video is to try to make the list on your own, hit pause, and then come back and see if you matched what I wrote. Did you miss something, or did you add something that maybe I didn't write in, which is absolutely possible. So looking at a rhombus, so just a quick drawing, usually people kind of make it look like a parallelogram. So you got rhombuses, and one of the first uh, characteristics that it has is it has four congruent sides. So that's something that is different from the parallelogram. Uh, we know that a rhombus doesn't have any 90-degree angles, or else it would be a square. The other big characteristic that we have is when we look at the line segments in between them, if you have two diagonals, they are going to bisect just like the parallelogram, but they're both going to bisect and they are going to make a 90-degree angle. So you're going to say diagonals intersect at 90 degrees. So that's something that's different. So looking at a rectangle, again, that is a parallelogram. But the one thing that a rectangle has specifically is it's going to have four right angles. Opposite sides are congruent. Same thing as a parallelogram, but that's kind of uh, the big characteristics of the rectangle. Uh, Square we have here, and kind of a combo of a rectangle and a rhombus, where you now have four congruent sides and also four right angles. Okay, square kind of falls in both the characteristics of a rectangle and a rhombus. So, so this is kind of, if you look here, this is kind of, if you look at the box here, it says quadrilaterals on top. Quadrilaterals are any four-sided figure, or polygon, we'll say. And of the quadrilaterals, it can be a parallelogram, which means that the opposite sides are parallel. From that, you can kind of make it into a smaller subset where you say, okay, you have rhombuses where you have four equal sides, you have rectangles, and you have four right angles, and then you have the square that kind of gives you a mix of both of those characteristics as well. So with that being said, um, we can classify the quadrilateral, and then we get to explain and find the values for x and y. So right off the bat here, it has four equal sides, or four congruent sides. So we know that it's possible that it can be either a rhombus or square, but we have this 97 degrees, so we know that it can't be a square because it has to all four of them be 90. So we are going to classify this as a rhombus. All right, so my explanation was we have four congruent sides. That's going to be the rhombus. It's the most specific name that we can have. All right, from here, finding the values of x and y. Since this and these two sides will be the same, we can set them equal to each other. So I can say that y plus 12 is equal to 5y. So I'm going to subtract y from both sides. Now I got 12 equals 4y, divided everything by 4, y will equal 3. All right, here, even though it's a rhombus, it still holds the same characteristics as a parallelogram. We were told that consecutive angles would be supplementary. So all we have to do to find x is take 180 subtracted by 97. That's going to equal x. So 180 minus 97 gives us 83. So x is going to be 83 degrees. Okay. So, excuse me. In this one here, we see we have four right angles. So we know that it can either be a rectangle or a square. Just because it may look like the sides are not, all four sides are not congruent, that doesn't mean that they are. You can't go by just the drawing itself. So what we got to do is go about and solving them and then see what those measurements actually are to make that conclusion. So we know that this side and this side will be the same, and this side and this side will be the same. So with that being said, we can let's solve x and y first before we make our decision on what classification of what quadrilateral it may be. So first off, I can take finding y. So I got y minus 6 is going to be equal to 2y minus 18. From here, I'm going to subtract y to both sides, add 18 to both sides. So that gets canceled out. That gets canceled out. Negative 6 plus 18 is 12. 2y minus y is just going to be 1y, so that's y. So y is 12. To find x, same process. I'm going to take 4x minus 32, set that equal to 2x plus 46. I'm going to subtract 2x from both sides, and then I'm going to add 32 to both sides. So that'll cancel, that'll cancel. 4x minus 2x is 2x. And then 46 plus 32 will equal 78. And then dividing everything by 2, x is going to equal 39. Okay, so now I know that x is 39, uh, y is 12. We can see what the measurements are going to be. So I have 39 times by 2 plus 46. That gives me 124. 39 times 4 minus 32, so I get 124. So 124 on both of them checks off. That means we did the math right for the value of x. So now I got 2 times 12 minus 18 is 6. And then I got 12 minus 6 is 6. All right, so I got side measurements of 6 and 6, 124 and 124. They're not the same. So my, because of 4 right angles and not having 4 equal sides, my classification is a rectangle. Okay. Finally, it says here that the diagonal of a rhombus ABC intersects at point E. So this is where point E is located. They want us, says given angle and side measurements, find the indicated measure. So they want us to find the measurement of DAC, the measurement of ADC, line segment AE, and line segment DB. So it says it's a rhombus. So one of the things that we can conclude from that is that this is at 90 degrees. So with that being said, let's look at um, the first one here is D. So I'm gonna just write a different color. DAC. All right, so we're trying to find this angle right here is what they're looking for DAC. Okay, so what we can say here is since this is 32, to help us find that out, let's figure out what this one is, because we have all the information right in that triangle right there. So I could say that 180 minus 90 minus 32 is going to be 58. So this right here is 58 degrees. Okay, which means that over here would be 58 degrees. Over here would be 32. This would be 90. This would be 90. Okay. And then what we can say with that is what we're going to do is call that, let's see. All right. So I was double checking the book, and there is another characteristic, another theorem that we didn't go over, which I forgot. Sorry. One of the things that if it is in fact a rhombus, that we can also say that when you have a diagonal that also, that bisects each other, which is the same thing as parallelogram, we can also say that the angles also bisect. So this angle will be the same as this angle. So since that is 32 degrees, we can say that angle DAC is also 32 degrees. Let's write in 32 right here. So then this bisects here, so this is 58. This is also 58. This is 32. With that being said, now I'm looking at A, D, C. So essentially it's going to be 58 plus 58, which equals 116. And one of the things that we can do to see, make sure that works out is say, okay, 116 plus 116 plus would be what, 64 plus 64 should give us 360, in which it does. So because we know that a quadrilateral has four sides, the sum of any quadrilateral is going to result of 360 degrees. Okay, so I'm just going to kind of erase this to kind of give us a clean slate to look at the side measurements. And they want us to find the value of AE, which is right here. Well, they're telling us that EC is 10, so this is also going to be 10. DB, which is the distance from here to here. We don't know what that is, but we know that this is a right angle. We know that this right here is going to be 10, and we know that since this is 32, we know that this is going to be 32. We also have our trig ratios to help us find out that value. So we have 32 degrees, that's opposite over adjacent. So now I have the tangent of 32 is going to be equal to opposite, which we don't know what it is, so we'll just call it x over 10, which is the adjacent. All right, so multiply both sides by 10. So now I have 10 times it by the tangent of 32, which gives us our value of x, which is roughly 6 point, we'll say 25. So this is 6.25. And then they wanted to find dB, which is the whole thing. So it's going to be 6.25 times it by 2, which gives us about 12.5. And that is looking at the properties of rhombuses, rectangles, and squares. Hope this helps. Until next time.